So in this video, we're going to look at something called sign charts. Okay, so sign charts are a way to show us the relationship between the function and its derivatives. There's two ones we'll do. There's a first derivative sign chart and a second derivative sign chart. And in this video, we're going to focus on the first derivative sign chart. So the first derivative sign chart has three parts. It has the x values, which are given in intervals or a single number. Okay, so that means x equals -5. On this interval, we have x's from -5, negative infinity to -5. Then we have what's happening with the derivative at each of those x values, and then what's happening with the original function. So we're going to fill in what's happening with the original function. So we have to know our relationship. So going back to that chart, we're looking at this column and saying, okay, what do we know about f of x? So if, again, my derivative is greater than 0, we know my function is increasing. If my derivative is less than 0, my function is decreasing. Okay, so I'm going to fill that in for this chart. So from negative infinity to -5, my derivative is negative, which means my original function is decreasing, and I put DEC for that. Okay. From -5 to 4, my derivative is positive, so my original function is increasing. From 4 to 8, my derivative is positive, so it's increasing again. And from 8 to infinity, my first derivative is negative, and so my function is decreasing. So I would fill those in first. And then we want to say, okay, what is happening at -5, 4, and 8? And I think it helps to draw a picture of this than trying to like memorize the rules here in this chart to figure out if it's a max, min, or plateau point. So anytime the derivative is 0, we have three options. It's a max, min, or plateau point. So here at -5, what we're saying is, okay, before -5, from -5, negative infinity, -5, my function is decreasing. Then it levels off, the slope is 0, and then it starts increasing. And if you draw a picture, it helps you to see, okay, that means that's the lowest point and that's a min. And so at x equals -5, we have a min. And I'm going to do that for each of these locations for my critical values. So at x equals 4, my function was increasing. At 4, it levels off, but then it continues to increase. And so that is an example of a plateau point, and I use PP for plateau point. And then at 8, before 8, my function is increasing. It levels off at 8, so the derivative is 0, and then it's decreasing. And so I can see from my picture that that is a max. And so I believe drawing the picture instead of trying to like memorize those rules helps you understand both the relationship between the derivative and f of x and be able to easily fill in the max and the mins. Okay, so this is called a first derivative sign chart. We can also draw them from graphs. So again, sign charts are helpful in determining max, mins, where a function is increasing, decreasing, and a concavity we'll get to when we get to the second derivative. So we want to make a first derivative sign chart for this graph. Okay? So first thing I have to figure out is my intervals for the x. So my function starts at -3, open parenthesis because it's an open circle, and it goes until -2, and then it changes direction. So we're going to find again those critical values first, and that's going to determine the separation for my interval. So my first critical value is x equals -2, because again, the derivative here is 0. Then my function is increasing until I get to 0, and then the derivative again is 0 at 0, so that's my second critical value. And then my function stops at 1. Okay? So my intervals for x are negative infinity to -2. Okay? Then I'm going to put my critical value of 2. Then I have from 2 to 0, this interval, sorry, -2 should be to 0 where it's increasing. Then I have 0. And then I have from 0 to 1. And this should be technically, my graph doesn't go to negative infinity, it stops at -3. So I have -3 to 2, -2. Okay. So these are all of my intervals. And on one, we can put a bracket because it is included. For all of these other intervals, when we're talking about increasing, decreasing, we always put parentheses on it. Because at -2, it's not increasing or decreasing. The derivative is zero. Okay, so then we're going to put what happens with our derivative and with our f. So I'm going to first fill in f because I have the graph of f and I can easily see what's happening. So we know from -3 to -2, my function is decreasing. Okay, so f is always increasing, decreasing, and we're talking about max and min. At -2, I have a min. From -2 to 0, my function is going up, so it's increasing. At 0, I have a max. And then from 0 to 1, I'm decreasing. Now we're going to just fill in what we know about the derivative based on this. So again, if my function is decreasing, and you can draw the tangent line across, so my slope is negative, so the derivative is negative. And you can put negative or you can put a minus sign, either one. At a min, the derivative is always equal to 0. When it's increasing, the derivative is positive. Here again, or you can put a plus sign. At a max, the derivative is 0, and when it's decreasing again, the derivative is negative. And again, to help you if you have the graph, you can draw the tangent lines to see what is the slope. Is it going up? So it's increasing and the slope is positive, or it's going down and the slope is negative. Now, this is one way to draw a sign chart. Another way that we often draw a sign chart that sometimes is a little bit faster is with a number line. And so for the number line, we just put the critical values on here and the endpoints. So I would put -3, -2, 0, and then 1. It doesn't have to be equally spaced. You can if you want how a number line would be. And then I'm going to fill in, okay, so from -3 to -2, my function is decreasing. And usually we just use arrows, but you could also write decreasing. From -2 to 0, my function is increasing, so I'm going to put an up arrow. And then from 0 to 1, my function is decreasing. Okay, so from -3 to -2, I know that my derivative is negative. From -2 to 0, because my function is increasing, my derivative is positive. And from 0 to 1, my derivative is negative. At -2, f has a min. And at 0, f has a max. And that means the derivative at those 2 points is 0. So this is also another way to sign chart. It also helps to see, because it is a interval that this graph starts at -3 and ends at 1. So it's kind of called a closed interval. We can see at the endpoint at -3 that f has a max because my graph started up and then it went down. So at -3, I have a max. And at 1, I have a min because my function was decreasing until that point. So you may also draw your sign charts this way. If you draw it this way, though, you have to label what's happening with f and what's happening with f prime. So you need to show the max, the mins, the increasing, decreasing with arrows, and then the derivative, the negative and positives, and where it's 0. And so either way is acceptable. The one that you might have to fill out on the homework or the exam is going to look something like this, though. So we can use sign charts to help us answer questions like this to show, again, the relationship between the derivative and the original function. So it says, determine the characteristics of f of x given the following information. The derivative is greater than 0 from -infinity to 3. It's equal to 0 at 3. And the derivative is less than 0 from 3 to infinity. So again, you can draw a sign chart to kind of help you visualize what's happening and what is going on with f of x. So again, we have my intervals from -infinity to -3. X is 3, and this is the x value, and from 3 to infinity. And I have what's happening with f prime and f. So with f prime, I know it's greater than 0, so it's positive on -3. It's 0, and then it's negative from 3 to infinity. And so my function is again increasing, so it's going up. And then from 3 to infinity, it's decreasing and going down. And then we can see, again, if I draw kind of a picture, it's going up and then it's leveling off and going down. And so that means at 3, I have a max. Right? And so that's what I would say. I would say F is increasing from negative infinity to 3. X equals 3 is a max, is where a max occurs. And F is decreasing from 3 to infinity. And that's what I know about F. Those are the 3 things I know. And this sign chart helps me to visualize or see that. So a second one, F of X is continuous from negative infinity to infinity, and it has one minimum at the point negative 3, 4. There are no maximums. Okay, so they didn't give me as much information, but they told me I have one minimum. So if I think about a graph and plot the point negative 3, 4, I know that my graph is continuous, which means it has no breaks or jumps, and it has a min at this point. So it goes down to this point, and then it goes up forever, and there's no max. And so I can see that my function is decreasing until I get to negative 3, and then it's going up and increasing until I get to 3. So what do I know? If I draw again my sign chart to show the relationship, I know my X value is 3. So from negative infinity to 3, negative 3. And then from negative 3 to infinity, that's my only critical value. I know that F is decreasing, so the derivative is negative from until we get to negative 3. At negative 3, because it's a min, the derivative is equal to 0. And from negative 3 to infinity, my function is increasing, and so it's positive. And often questions like this will be multiple choice, like which one is true, and you will have to say which one is true. So everything that we know that F prime of X is less than 0 on negative infinity to negative 3. We know F prime of negative 3 equals 0. Okay, it's always the X coordinate that we're talking about. We know that F prime of X is greater than 0 or positive on negative 3 to infinity. We know that F of X is decreasing on negative infinity to negative 3, and F of X is increasing on negative 3 to infinity. Okay. And then we again know that there's a min at negative 3, 4, but they told me that. So this kind of summarizes everything we know about this graph just from this information. Now, on the homework, they have 2 examples like this, where they want you to fill in this table. So F prime of X is continuous for all X. F of X has a local extreme value at X equals 4. Okay, so again, a local extreme is either a max or a min. So it has a max or a min at 4. And then it says fill in this table. So at 1, what happens at 4 and at 7? So it's pretty vague. And instead of putting intervals, they put just an X value in each one. But what we know is that because it's in a local extrema, we know that the derivative at 4 has to be 0. And then we know before 4, so at like 1, the derivative has to either be positive or negative. And at 7, it has to be the opposite because it's a local extreme. So it doesn't matter if you say min or max, you can either do one. If you want to say it's a max, what you'll say is at 4, the derivative is equal to 0. Before 4, if it's a max, the derivative would have to be positive. So since 1 is before the X value 4, we would say this is positive. And what they want you to actually do is just to put any positive number in there. So on the homework, they expect you to put a number instead of just positive or negative. So I'll just put 3. And then at 7, which is after 4 on a number line, the derivative for it to be a max would have to be negative. So I'm going to pick any negative number. I'll just say -3. And then you'll fill in this information. Based on your table, f of x is blank until x equals 4. So because my derivative is positive, it's increasing. N is, this should say, is decreasing after, because after 4, my derivative will have to be negative. The function f of x will have a maximum at x equals 4. And that's what they want you to fill in. Now, because they just said local extrema, I could have made it a minimum. And so if I did a minimum, what I would just change is I would make my number for 1, I would make the derivative negative. So some negative number, again, I'll just use -3. And at 4, it would still be 0. And then at 7, my graph would be increasing if it's a min. And so I would pick a positive number. And then you would just switch this. You would say, based on your table, f of x is decreasing until x equals 4. And increasing after, so be positive. And then f of x will have a minimum. So you can pick on this problem if you want it to be a max or a min, but you have to make sure you fill in the correct terminology based on your table. Okay, so one more very similar from the homework. F prime of x is continuous for all x. F of x does not have a local extreme at x equals 4, but f prime of 4 equals 0. Complete the table. Okay, so again, we know f prime of 4 equals 0. If it does not have a local extrema, what that means is my function is increasing, levels off, and then continues to increase, or is decreasing, levels off, and continues to decrease. And again, this is called a plateau point. Again, I use PP for plateaued point. So what that means is that the derivative does not change sign. So you can either make the derivative positive before and after, or negative before and after. It doesn't matter. Just make sure then you tell me what f of x is doing, either increasing or decreasing based on what you picked. And you are going to pick a number, not just write negative or positive. So I could say, like, again, for 1, I could say -2. At 7, I could say -3. And then based on my table, f of x is decreasing until x equals 4 and is decreasing after. And then f of x will have a plateau point at x equals 4. Now, on your homework, they don't give you the option of plateau point. You'll instead say neither a max or min. So we call it, the technical term is a plateau point, but on your homework assignment, they just say neither a max or min. So that way you'll pick. And again, it could be opposite. You could have made it a positive number and a positive number and then put increasing and then increasing, but it would still be neither a max or min. So that's the information on the first derivative sign charts.